All right, continuing on with chapter 3, we just left off with rate and regularity. So now we're getting into P waves, PR intervals, and the QRS complex. And we'll wrap up chapter 3. So with P waves, we want to make sure that they're upright and round. Again, we're looking at lead 2. There should be one P wave before each QRS complex, and they should all be the same shape. I just emphasize lead 2. Lead 2 is the one that's kind of down at the left hip and picking up the electrical activity from that viewpoint. All right. There are other leads in the 12 lead that are viewing the heart from different angles. And depending on which one we're looking at, sometimes the P wave can have a biphasic shape where it's actually going a little bit up and a little bit down, and that would actually be normal. So again, with basic EKG interpretation, lead 2 is your go-to. So those look good. And then if we look at this rhythm, you can see this one's quite a bit faster. This is sinus tachycardia. I know that this is sinus tachycardia because these P waves are all upright and round. All right, so they're normal P waves. And the reason I know it's sinus is because of the PR interval width is within normal limits, which we'll see on the next slide. All right, so a couple of examples of normal P waves. And then now we have normal P waves, but we have dropped complexes. So in this case, we have more P waves than there are QRS complexes. And when you have this, it indicates that there's a block. In other words, some of those signals that are being generated by the sinus node are not making it to the bottom. It indicates that this person has a heart block, and this could be a serious condition. So it's something that you want to check your patient and make sure that they are perfusing enough to keep their brain and vital organs and themselves alive. All right, so moving over here, we've got an example of P waves that are not upright and round. Those P waves are upside down. They're a little bit tight to the complex. This indicates that we have what is known as a junctional rhythm. Those P waves are upside down for a reason. It's because the electrical activity is being generated in retrograde. It's actually going backwards. When we get into that chapter, which I believe is chapter 6, we'll get into that in a little bit more detail. All right. These are not measurable P waves. These are kind of like fibrillatory waves. So this rhythm would be known as atrial fibrillation. And then the next one is atrial flutter. Those are not normal P waves either. So those are flutter waves, sometimes called F waves. And this indicates that the atria is beating 4 times. In this case, it's beating 4 times for every one ventricular electrical rhythm that's being generated. All right, and then the last one is a rhythm that we call SVT, short for supraventricular tachycardia. So the reason we call it supraventricular tachycardia is because those QRS complexes are narrow. That indicates that the origin of conduction for this rhythm is somewhere at the top of the heart. Okay, rhythms that are generated in the ventricles tend to have a very wide QRS complex. So because this one is narrow, we know it's coming from the atria somewhere, but we can't tell because it's so fast. All right, this could be atrial flutter. I mean, that little pointy wave doesn't look a whole lot different from leads, right? So it could be atrial flutter. It could be a junctional tachycardia, and we're actually looking at T waves. Uh, in other words, it could have P waves like this that are being buried in the T wave, and it could be sinus tachycardia. So we don't know. So the beautiful thing about that is when it's going this fast, we just call it supraventricular tachycardia. So there's a few examples of P waves. Now we get into PR intervals, and those should be between 0.12 and 0.20 seconds long, or 3 to 5 small boxes. And the other thing you're going to measure, are they precisely equal to each other? Okay, so looking at this first one, you have a PR interval measured with the caliper here that is about exactly 4 small boxes apart, or 0.16 seconds. Okay, You see the image of the ruler there? You can use a ruler as well. They make EKG rulers. If you Google EKG ruler, you'll see a whole bunch of different choices come up, and that can be a really helpful tool for someone learning. All right. So if we're going to measure this one, again, this is the same rhythm strip as the one before, but you can't measure this. There's no QRS complex to measure a PR interval, but we can measure each one of these, right? So we kind of start here. We count 1, 2, 3. Looks like about 3.5 boxes. So that would actually be 0.14. I'll never go in 3/4 or 1/4 of a box, but I might break a box in half with my analysis. Again, this is basic EKG recognition. If you're looking at this at the cardiologist level, you're not doing these decimals. They actually look at it in milliseconds. Why everybody doesn't do the same, I don't know. I didn't make that decision. I just kind of follow the rules. So moving over here, these are PR intervals that are not measurable. You can't measure a PRI in atrial fibrillation. You can't measure a PRI in atrial flutter. And then with SVT, it's kind of the same thing. We don't know if that is a P wave. We don't know if that's a flutter wave. We don't know if that's just a T wave. Okay, so moving on to our last one, the QRS complex should be less than 0.12 seconds or less than 3 small boxes. And with this first example here, you can see we get our calipers out and it measures about 2 small boxes apart or 0.08 seconds. All right. With this one, that is a wide complex QRS, isn't it? Notice that there's no P wave before there, and that indicates that this is a ventricular in origin rhythm. All right. There's another ventricular rhythm. Many of you might recognize that as ventricular tachycardia. So there's the calipers, and then you can kind of see the, if I come over here with my cursor, you can see your change of direction is occurring right about there. Move over to this one right about there. And then the change of direction on the other side is up here. So I got these arrows pointing to those locations, and it measures about exactly one big box or 0.20 seconds. And then you have ventricular fibrillation. These are fibrillatory waves, and there's no really obvious beginning to end. And honestly, with this patient, you're probably doing CPR, and hopefully you've got the pads on and doing a defibrillation as early as you can. All right, so that's it. Next, we will get into chapter 4 and start talking about sinus rhythms.